Hello everyone, let's solve a problem from GATE 2016 Aerospace Engineering paper question number 16. So let x be a positive real number. The function f of x square plus 1 by x square has its minima at x is equal to dash. So we have to find the minimum value of this function. For that we have to differentiate this once and equate it to 0. So in order to know whether it will give minima or maxima, the second derivative has to be greater than 0 for this function to give a minima value, right? Let's go and solve this. This is the function given for us, x square plus 1 by x square, right? So its first derivative will be 2x minus 2 by x cube, right? So its second derivative will be 2 minus, so let me just write it in this way, 2x minus 2x power minus 3, right? So if we just differentiate this, minus 2 into minus 3 x power minus 3 minus 1, right? So what we will get, 2 minus, so minus into minus will give us plus 6 x power minus 4, right? So the value that we will get is 2 plus 6 by x power 4, right? So let's find the minimum value. We have to equate this function to 0, so then we will get 2x minus 2 by x cube equal to 0. 2x is equal to 2 by x cube, 2 will get cancelled, then x power 4 is equal to 1, and then x is equal to plus or minus 1, right? So we can have value plus 1 or minus 1, okay? But since it's given in the question x is a positive real number, let's take only the positive value, right? Let's just check whether it's a minima value. If we just substitute in the second derivative, it has to give the value greater than 0, right? So f double dash of 1 will give us 2 plus 6 by 1 will get 8, which is greater than 0, so this will give us minima, okay? So the value x is equal to 1 is the minima for this function, okay? So the function f of x square plus 1 by x square has its minima at x is equal to 1, right? So if you want to know more about the concepts of maxima and minima, you can refer to the NPTEL course from Professor Jaydeep Dapta. The course name is Basic Calculus for Engineers, Scientists and Economists. The particular lecture for this question is Maxima and Minima, which is lecture number 10 of that course. You can also see the YouTube link for that lecture here. So that's all for this question. Thank you.